parallel communication. Okay. So which one will be faster, serial or parallel?
Parallel.
So basically parallel only will transfer fast, right? But when you see SAS protocol, SAS gives more speed, like 24 gig it supports. But SCSI is a parallel protocol, but it supports only 8 Gbps. So why it is like that?
Data corruption is more in parallel communication compared to serial.
So in parallel, data corruption may be there, right? Why? So since we are transferring multiple commands, so from host to the target, there is a high chances for the data corruption. Okay, but in case of serial communication, since only one bit is transferring at a time, only one command we are transferring at a time, there will be very less chance of data corruption or data collision. So in between the host to the target. Okay. So which one is costlier? So parallel, let's say if you have parallel communication, since more bits, more commands will transfer at a time, so implementation cost will be more. So in case of serial, since we send only one bit at a time, only one command at a time, cost will be less. Okay. Okay, so write this difference between parallel and serial communication. So draw this diagram and write 2-3 differences. Okay. Huh? Okay, so depending on the protocol that we use, so these two are divided into two protocols, so hard disk protocol and transmission protocol. So the protocol where we used to store the data. So let's say if we are using some HDD or SSD means that has to be built with some protocol, right? So when it comes to hard disk protocol, whatever the SCSI, ATA, SATA, SAS, NVMe. So these are all the hard disk protocols where we used to store the data. So when it comes to the transmission protocol, okay, so where we used to transfer the data. Okay, so let's say where we used to transfer the data. So there are iSCSI, FC, FCOE, or NVMe over Fabric. Okay, so over the network or between the two places, if we want to transfer the data, so those protocols, we call it as transmission protocols. So till now we are studying about hard disk protocols. So we covered SCSI, ATA, SATA, and SAS. So today we will see about NVMe. Okay. So NVMe is a very important protocol. So this is the recent enhancement that is happening in the storage side. Okay, so this is the most recent protocol. If you see SAS, SATA, iSCSI, FC, so those are the very old protocols. So many people are already using those protocols. So NVMe came into market in 2018 or 19. Okay, so NVMe is much popular. So it is much powerful. So when we compare with other hard disk protocols. So basically NVMe stands for non-volatile memory express. Okay. So if you see these traditional protocols like SCSI, SATA, or ATA, so if you want to implement the storage connection with those protocols, we need one host and server, one host and one target. So in the host, we need a special adapter, that is host bus adapter. We need HBA, right? Okay. So from the HBA, we will connect this storage with target using the cable. Okay. So in case of NVMe, so let's say you're using SAS drives or SATA drives, we need to connect to this storage device, so like HBA. Okay, so this one we need to insert in PCI. This HBA we need to insert in the PCI. So this device can be SAS or SATA, or it can be ATA. So let's say in case of SAS or SATA, if we are sending some command, if we are sending some data from host to the target, so the data has to come to the HBA. So HBA has to receive the data. So from the HBA, so it will send this data to the drive like this, right? Okay, so if any command is coming from the host, let's say someone is sending the data, so HBA has to receive the data and it has to send to the target. So target means SAS or SATA device via these cables. So in case of NVMe, so these NVMe devices are directly connected to the PCI slot. So this is a very important point. So we will see this architecture, how it looks. Okay. So this is the connection with NVMe and above is the SAS based storage solution. Okay, so if you see the command flow, In case of SAS or SATA, so the command has to come from the host. So HB has to receive the data and it has to send to the SAS or SATA drive. So, but in case of NVMe, so since these NVMe drives are directly connected to the PCI slot, okay. So whatever the data that comes from the host, so it will directly go to this NVMe drive. So here the path, so the path for the command to reach the target is reduced. So here it will take very less time, right? So directly, since these drives are directly connected to the PCI slot, so it will take very less time compared with the SAS or SATA. So now if you see latency, so what is latency?
How much time taken by command to pass?
Yes, so time taken by command to reach the target, right? So in case of SAS, so it will take more time or less time if we compare with NVMe. So you just compare these two diagrams and tell, so which one takes more time, SAS or NVMe?
SAS.
SAS, right? So why? So the command has to come from the client. So it has to go through this HBA. From the HBA, the command will travel to the drive. In case of NVMe, the command is directly going to the target. Yeah, so these NVMe drives. So for any storage system or any computer or laptop or server you take, so CPU is the main thing, so which is responsible for processing the data. So whatever the operation that we do, so it has to go through a CPU only, right? Okay, so this NVMe device, so the path you can see, so here the distance between CPU and this target SATA drive is more, right? So if you compare with NVMe, so this distance is more. Okay, so you can see less latency in case of NVMe. Okay, so next we will see about throughput. So what is throughput?
Advanced command is from host to target.
Throughput is nothing but speed, right? So which one takes more time? Which one takes more time and which command flows in more speed compared to NVMe or SATA or SAS? So since these drives are directly connected in CPU, PCI, so throughput will be more, okay, in NVMe. So latency will be less. As throughput is more and latency is less, so the IOPS also will be more, okay. So how we will measure latency?
Milliseconds or microseconds.
Okay, throughput,
Mbps.
so Mbps, IOPS,
Numbers.
numbers, right? Okay. So now if we compare with SAS and SATA with NVMe, so NVMe is 100 times faster than SAS. Okay, so there is a huge difference in the speed. So everyone in the market, they are going for NVMe devices now. But implementation of NVMe is very costly compared to SAS and SATA because these drives has to be directly connected to the PCI slot. So since it is a PCI interface, so PCI cards are very costly compared to this backplanes that we use in the traditional protocols like SAS or SATA. Okay, so now NVMe is, so there is no fixed size, fixed speed in NVMe. So we call NVMe is 100 times faster than SAS protocol. Okay, so what is queue depth?
Number of commands that HBA can.
Okay, number of commands that HBA can hold, right? So before queue depth, we have to know about queue. Okay, so in case of SAS or SATA, so it supports queues, there will be only one queue, right? So this is very, very important point. So in case of SAS and SATA, there will be only one queue. So this one queue can hold up to 32 commands in case of SAS or SATA. So if you see NVMe, so NVMe contains more queues. Okay. So NVMe contains more queues, that is, it can have 64,535 queues. Okay. So again, each queue can hold 64,535 commands. Okay. So if you see the queue depth comparison between SAS, SATA and NVMe, there is a huge difference in the queue depth. Since queue depth is more, we can see more performance. Since queue depth is more, we can see more IOPS, less latency, and more throughput. Okay. So now how many queues supported in NVMe? So NVMe works based on queues. Okay. So NVMe supports up to 64,535 queues. Again, each queue can hold up to 64,535 commands. Okay. So since the queue depth is more, so what is the queue depth of NVMe now? What is the queue depth of NVMe? So 64,535 commands, right? So that is the queue depth. So how many queues NVMe supports? తింటున్నారా అందరూ నిద్రపోతున్నారా?
64,535.
ఓకే. సో 64,535. మీరు రెస్పాన్స్ అవ్వకపోతే నేను వీడియో ఆన్ చేసి క్లాస్ చెప్తా. వీడియో ఆన్ చేయమంట క్లాస్ చెప్పేప్పుడు. Okay, so NVMe supports 64,535 queues, and again each queue supports 64,535 commands. So how many queues supported in SAS or SATA?
Only one queue.
One queue. So what is the queue depth of SAS or SATA?
SATA 32.
So SATA 32, right? When it comes to SAS, it is 256. 256. Okay. So just add these 2 points in SAS and SATA. So SAS SATA ఈ points యాడ్ చేసుకోండి. SAS supports one queue and it can hold 32 commands. SATA. SAS has one queue and it supports 256 commands. 2 points యాడ్ చేయండి ఫాస్ట్ గా. యాడ్ చేశారా 2 points? Okay, so how we will identify SAS device?
WWN.
So
WWN.
WWN. Similarly, NVMe we can identify with NVMe IDs. Okay. So రాసుకోండి ఆ 2 పాయింట్స్ రాస్తే you can write this about NVMe. So we'll continue about NVMe again. So similarly for SAS, SAS uses SCSI commands, right? And SATA uses SATA commands. So NVMe has its own command sets. We call it as NVMe commands. So NVMe commands are very powerful. So and very less commands. So we have only around 32 or 13 commands in NVMe. But in case of SCSI or ATA, we have more commands, right? So the working mechanism also very different. So when we compare this NVMe and SATA, so those protocols works with HBS where we will connect drives to the HBS. So here we are connecting drives directly to the PCA card. Okay. రాయండి రాసారా Okay, hang on. So now we will see about the form factor. So we know HDD form factor is 3.5 and SSD form factor is 2.5, right? So when it comes to NVMe, so NVMe form factor will not calculate in inches or 3.5 inches or 2.5 inches. So rather than we call it as M.2, U.2 and E.2. Okay, so these are all the form factors of NVMe. So I'll show you these drives. Hello. Okay, so these are all the drives. So M.2 drives. So it looks completely different when you see those HDD or SSD. Okay, so this is the M.2 drive. You can see here, right? So this is the M.2 drive. Okay, so this is the M.2 drive. So one more point is, as of now, NVMe drives are available as only SSDs. Okay. NVMe drives that are available in market, those are all SSDs. So you can see this interface. So this part we will insert in the PCI slot. These are all the NANDs that are present in SSD. Okay. అర్థమైందా? సో ఆ పాయింట్ యాడ్ చేసుకోండి. Form factor of NVMe is M.2, U.2 and E.2. So you can type M.2 and U.2 and E.2 and you can observe the difference. Okay. So next. So basically NVMe works based on queues. Because as I told earlier, so it works very differently when you compare with SATA SATA. So NVMe works based on the queues. So there are two types of queues. So one is submission queue. Another one is completion queue. Okay. So we'll see how these queues works and how the transfers between host to the target. So unlike this so the commands will go through those layers. But in case of NVMe, as it works based on the queues, the commands will flow through the queues. Okay. So now we will so let's say this is the host, this is the target. And we know there are two types of queues. Thank you. One more.
Recording stopped.